Okay, so let's look at another example in acidic solution, and we're going to go through the steps and follow the same process as before. We're going to divide the skeleton equation into half reactions, so look at the MnO4 minus changed into MnO2, and the C2O4, which is oxalate, changed into carbonate. So we're just going to put them in our half reactions there and follow the steps. So let's take one half reaction at a time, the MnO4 to MnO2. If I balance the atoms other than H and O, the MNs, that's what I'm going to balance first, then they're balanced. We'll have one Mn here and one Mn here, so that's fine. So the next thing I do is I look for the oxygens, and I have 4 oxygens here and 2 here, so I really need 2 more oxygens over here, and I do that by adding water. And then I should balance the hydrogens I just added. There are 4 hydrogens I just added there, and I'm adding 4 H pluses. That's how I add hydrogen. Remember, it's an acidic solution. And then to determine the total charge on both sides and to make the charge the same. If I add the plus 4 from the 4 H's and then the minus 1 from the Mn minus charge, I get plus 3 on the left-hand side. MnO2 and H2O are both neutral, so I have 0 on the other side. And so to make them the same, remember I can only add electrons, so I'm going to add electrons to the more positive side. I should add 3 because adding 3 is like subtracting 3 on that side, and that should make that side 0. So this half reaction is all done, and we'll look again, because I'm adding electrons to the left hand side, it's a reduction. My manganese is going down from 4 oxygens to 2 oxygens, so I'm reducing the number of oxygens, and if we worked out the oxidation numbers, you'd see that occur as well. So I want to do it for this reaction, and I need to go back up to step 2, balance my atoms other than hydrogen and oxygen. I can't tell you how many times that this gets forgotten because it's usually a 1, but here it's going to matter quite a lot. There's 2 electrons here, or sorry, 2 carbons here, there's 1 carbon here. We want to balance it by putting a 2 in front of that, and then balance my hydrogens, or oxygens I should say. I have 4 oxygens on this side, and now because I put the 2 in front of here, I actually have 6 oxygens on the right hand side. So I need 2 more oxygens on the left, and I do that by adding water on the left hand side. And of course I have added hydrogen to the left hand side, so I need to add enough hydrogens to the right hand side, and I add 4 hydrogens to the right hand side as H plus to balance that out. Okay, my elements are all balanced. I need to balance my charges by looking at my charges on the left hand side, 0 from the water, minus 2 from the oxalate, so minus 2 on this side, 2 times minus 2 from the carbonate, plus 4 from the hydrogen, so that's 0 on that side. I add to the more positive side. This 0 is the more positive side, so I need 2 more electrons. If I do that, I get minus 2 on the right hand side for both of those on this half reaction, which is an oxidation half reaction, because you're having the electrons on the right hand side. So the next step is to make the electrons lost equal the electrons gained. If I look here, there's 3 electrons from this half reaction, 2 from this half reaction. This is where you have to go back and look for common denominator, which for this 3 and 2 would be 6. So I need to multiply both half reactions by a factor, in this case 2 times this half reaction and 3 times this half reaction to get those 6 electrons. So I would urge you to multiply it out first, and don't forget to multiply each factor from that for the whole half reaction as well for the right hand side, and then add the 2, and we want to cancel anything that's the same on both sides, and of course our electrons are going to be what's the same, so I know I can cancel that right away. And then water, I have water on that side, water on this side. I have 2 waters left on the left hand side, and for my H pluses, some of those cancel out, so I get 4 H pluses on the right hand side. So now I write down everything that's left over, and I have my water there, my permanganate, the oxalate, the other manganese oxide, carbonate, and the H plus. And I check if all my elements are balanced. I have 2 Mn's, 6 C's, 4 H's, 22 O's, and my charges, I have minus 8 on one side and minus 8 on the other, so I'm all balanced.